Hello everyone, my name is Bhattanaga Saikaran and my partner name is YASHAS CH. We are third year CSC students from University BDT College of Engineering. To begin with, I would thank Emertxe Information Technology for providing me this opportunity to be part of this IoT internship. During this internship, we built a project on IoT based home automation solution. I would also thank project guide Jayalakshmi ma'am who taught us various concepts that were required during this internship. So, these are the contents which are learned by us. They are C programming, IoT, embedded systems, and microcontroller. This is basically an 1 month internship, and we have made a project. And the major things that are going to explain here are overview, objective, design elements, simulation, and conclusion. So, firstly, we are starting with C programming. It is a general purpose language. Even though it is an applied language, we use it efficiently in various specified domains. This is the structure of a simple C program, which consists of file header, preprocessor directive, the start of the program, and this is main body of the structure of C program.
Now I am going to explain the concepts which has been learned from the embedded C. Here we have learned the data types which are required like character, integer, float, double, and then the elements like modifier and qualifier in conditions and loops like for loop, do while loop, and operators like Boolean operators, then arrays and pointers, strings, functions, storage classes, and preprocessors. So now we are going to explain of Internet of Things. What do you mean by Internet of Things? Something we collectively network of connected devices which will be operated through a network is called as Internet of Things. Here, the technology that facilitates communication between devices over the internet. IoT system works through the real-time collection and exchange of data. You can observe here, the doctor is using his mobile phone for sensing, processing and analyzing of data, and also the signals and cars, whereas here the users of industries data is also propagating the data and applying it. In Internet of Things, there are various applications in this new world. Here, I have mentioned some applications which is based on Internet of Things. They are in automobile industry. We can do the wearable health monitors. In manufacturing unit, if we can manufacture the smart cars. In logistics and transport unit, we can do the smart buildings. And in business also, we can use Internet of Things for home automation.
So next topic is embedded systems. We all know that embedded system is combination of computer hardware and software designed for specific function. They are low cost, low power consuming small computers embedded in other mechanical or electrical devices. Generally, they comprise a processor, power supply, memory, and communication ports. Embedded systems consist of many applications such as they are used in many fields such as medical field, automotive industries, telecommunications, security systems, robotics, and electronics. We have some examples like CAT scanner, implanted heart monitors, electrical vehicles, household appliances. Microcontroller consists of analog to digital converter blocks and digital to analog converter blocks, timers and counters. We also have PWM, processors, memories and IoT ports, microprocessors and microcontrollers. It also consists of RAM, ROM and various types.
So, the overview of the project I am going to explain now. This project provides an IoT based home automation solution using Aurdino UNO board in PICSIMLAB simulator. Here, the hardware components which cannot be buy through hardware is simulated through our laptops in the Arduino Uno board. By using the Blink IoT mobile application, we used to maintain the server between our laptop and the hardware simulation and control the device remotely. Here, we use so many automations like controlling the lights, temperature of home, and inflow and outflow of water in the water tank. So, what are the objectives of this project? Connecting the home appliances to the Arduino PICSIMLAB simulator and integrate it with Blink IoT app using Blink Cloud. Controlling of lights, temperature of home along with the level of water tank using mobile app. Obtaining the notification about the status of home on mobile application. So, what do you mean by home automation and why it is used? Generally, people always don't stay at home. This brings the problem of home appliances not being monitored. The solution for this problem is home automation. Home automation enables the people to control most of the devices remotely, such as garden beds, volume of water present in the water tank, and temperature of the house or home.
So here we are going to discuss about Arduino Uno. Arduino Uno is a microcontroller board based on 8 Atmega 328P. It has 14 digital input and output pins, six analog input output pins, and 16 megahertz ceramic resonator, a USB connection, a power jack, and an ICSP header and a rest button. It can be programmed using different IDE. Arduino Uno IDE is used in project. Arduino Uno IDE supports C and C++ languages. This is a PICSIMLAB. PICSIMLAB is an open source real time emulator of development board with integrated MPLABX debugger. It supports some Pixel microcontrollers and some similar microcontrollers. It has integrated Arduino IDE for programming the
Now, I'm going to explain about the Blink IoT app configuration, how to create the new template, how to add device, how to select and add data stream, how to create icon, and how to include Blink library. Next, coming to light dependent resistor. In nowadays, light dependent resistor is a light detecting sensor that detects the light that falls upon it. The photoresistor is a light controlled variable resistor. The resistor of a photoresistor decreases with increasing incident light intensity. The LED lights are connected to the LDR via ADC, that is analog to digital converter. The ADC converts the analog input by the LDR into its equivalent digital form, which is then converted later by certain formula from 0 to 255 as upper bound. Based on that, we glow LED. Next, through using LED sensor, we have designed the garden light control using PICSIMLAB Arduino Uno board. The properties of the LDR sensor is applied to accomplish the controlling of the garden lights. During the day, the outdoor light is maximum, so the LDR sensor detects the light and the garden light is turned off. Whereas at night, the outdoor light is very low, so the LDR sensor detects the light and the light is turned on.
Next is temperature control system. The temperature is recorded using LM35 sensors, which read analog value. It also contains heating resistor and cooler. Analog value of temperature is obtained from the temperature sensor LM35 and display it on the CLCD after converting it into a digital value using ADC. Controlling the temperature of the system by turning on or off the heater and the cooler through the Blink app mobile application is possible. Water tank inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending commands through the serial communication and display the volume of water in the tank on the CLCD and also in the Blink IoT app. The tank refills itself when the outflow exceeds the threshold of minimum value of 2000 liters and it stops filling when the tank is full at 3000 liters. It gives notification to Blink IoT app. So this is the final output of the project.
of the simulator image. Here you are shown the LED set, and this is the CLCD board, and this is the LDR resistor board. This is a cooler fan, and the remote sensing object is here. Using this, we have designed a project which we will show in the further video. Using this LEDs, PICSIMLAB board, CLCD for cooler fan, we have designed two major projects. That is, one is temperature cooling system, and the other is serial tank inflow and outflow of water. And other thing is the light dependent garden light dependent object also we have created. So in the further slide, through conclusion, after explaining the conclusion of this slide, we are going to explain the real-time project we have designed using the PICSIMLAB and Blink IoT app. In the further video, we are going to explain. In this summary, this project provides a solution of monitoring and controlling home appliances and certain devices remotely. Using Blink IoT application, project is simulated where LED temperature system, serial tank resembles light, heater, cooler, and the water tank in real time. Blink IoT application allows user to control these devices according to the user's wish, thus accomplishing home automation. Thank you. Hello everyone, my name is YASHAS and I am pursuing third year computer science engineering from University VTT College of Engineering Davangere, and my partner Bhattanaga Sai Kiran. He is also pursuing his engineering degree from third year Computer Science and Engineering from University VTT College of Engineering Davangere. Today we are going to represent the IoT project which has been assigned by Emertxe group. Now, I will explain two main projects from here. One is the heater and cooler temperature cooling system, whereas the other is serial remote tank. First, I will go for home automation Blink IoT app. Press on Blink IoT app. Here it is. It has been connected to the simulator from my laptop. Here it is showing home automation. Click here. Okay. The home automation tab has been opened. Here, the first tab is representing the temperature cooling system, whereas the second tab is representing the outlet and inlet valve of serial remote tank. Now, I will show how it is going to operate. First, go to tab 1. Here, it is a CLCD which shows us the display of water flow, water inflow and temperature, where T represents the temperature, V represents the volume. Here, in represents the inlet and FL represents the flow. Off represents whether the switch is off or on. Now, I will press the heater as on in the tab 1. When I press the heater button on, the heater is on, the temperature is rising increasingly. Here, when it reaches 35 degrees Celsius, you can observe here the notification has been popped up as temperature is above 35 degrees Celsius, turning off the heater. Here, automatically the heater button has been turned off. Now I will press on the cooler button. When the cooler button is turned on, when the cooler button is turned on, the fan is running and the temperature is going down. When I press the cooler off and heater on, the temperature is going up, and when it reaches at 35 degrees Celsius, automatically a pop-up has been raised and the heater has been turned off. So this is about temperature cooling system. Here there is a gauge which represents the cooling of the system. When I turn the cooler on, suddenly the temperature is going to decrease. It is 32 degrees Celsius now. Now it has become 31.74 and so forth. So the cooling system is working successfully. Now I'm going to explain the serial remote tank now. See here, the blue color layer is going to represent the 3000 liters water syntax capacity. When the inlet valve is opened, the 3000 liters has been filled up. Now I will press on the outlet valve there where there will be the outflow of water and decrease in the tank capacity. When it goes for 2000 liters, there will be a pop-up for turning on the inlet valve and filling of water. Now I will press on the outlet valve. Okay. When I press on the outlet valve, you can observe the water capacity is turning off. When the water capacity is turning off, when it reaches 2000 liters, automatically the inlet valve has been on and the syntax is filling up. You can also observe here the gauge is also running successfully. And when it reaches 2000 liters, there will be a pop-up notification called as volume of water in tank is less than 2000, turning on the inlet valve, whereas the water in the tank is full, turning off the inlet valve. So both the serial water tank as well as the cooling system is working successfully. Now I will show the LDR working of it. When I when there is sunlight is high, the LDR will be uh, on and the LED represents the symbol of light on. When there is no temperature or the light on it LDR, the LED will be turned off. So this is all about our project, and we both, myself SSCH and Bhattanaga Sai Kiran, are thanking Emertxe group for giving us an excellent opportunity for internship, and we have made professional use of it. And thank you for it.